All right. Question to answer. What do I need to determine?
Amplitude?
Hmm?
Amplitude?
Amplitude. Beautiful. What's the amplitude? Yes. What does that amplitude mean? What does it mean? Good Lord. What does it mean, kids? What does it
From
mean?
the center line, it's 3 up,
Yes.
3 down.
From the midline, it goes 3 up, 3 down. I love it. What else can you determine?
Period.
Anybody remember? I'm going to ask you, but I want to see if you remember.
Step line?
We'll get to the step size. So, period. How do we get the period? Guys, how do I get the period? What's the period of sine?
2 pies.
What's the period of sine? Okay. Sorry. I've got to find something that works. What's the period of sine? In the first place, what's the period of sine? 2 pi. How do I figure out the new period?
Divide by 2.
Yes, because what's k? What's k? K. What's k? K is 2. New period is 2 pi over k. So sine normally takes 2 pi to do all its stuff. And then it repeats. This one is going to take just pi to do all its stuff. Okay. Say step size. Step size, guys. Step size.
The new period divided by 4.
Yes. That's how big. So sine normally goes 0 to 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi, yes. 1, 2, 3, 4 steps. If I smush it, there's still going to be those main things that happen every step, like 4 steps. So pi over 4, it'll be up here. Pi over 4, it'll be there. Pi over 4 to be there. Okay. That's why. Figuring out the step size, I got nothing. Figuring out the step size helps you figure out where it's going to do those things. Okay. What about, what's the last thing I haven't done yet? What's the last thing I haven't done yet? Sorry.
Phase shift?
It's very ugly. Phase shift. What do I need to do to figure that out?
Take number 2.
Say again.
Take number 2.
I got you. Because when you take something out, you're dividing it out. Because when you put it in, you multiply it. Oh my goodness gracious, I'm so sorry for you guys. I talk as bad as I write now.
Actually, writing's not that bad.
Well, maybe, that's the key. If I could really use my voice and not
Yeah.
So what's the phase shift?
Pi ups to the right.
Pi over 2 to the right. Now if you want to, I'm sorry.
You have to get x completely by itself to know that phase shift?
Yes. I want to know what's directly affecting the x. Yes. So all my inputs can now be pi over 2 bigger than they used to be. Yeah. Okay. If you want to, you can do begin and end. I don't really have to though. Because where am I starting? Where's everything starting? Normally starts at 0. That's the base wavelength that we do. Okay, if I could just stay right there, that'd be amazing. Okay, let's see. So 0 to 2 pi. Okay, so normally we start at 0. Where am I gonna start now? That's gone. Pi over 2. And in fact, I'm gonna be smart. I'm gonna be so smart. I'm gonna write this as 2 pi over 4. Because how big is my step size? So, sine, wherever it starts at what? What value? 0. Cosine starts at 1. I love it. Then what does sine do at the next step? And what is the next step?
3 pi over 4.
What's it do here? Oops. There we go. Amplitude's 3. Sorry?
Was it a maximum?
Maximum. Next step.
4 pi over 5.
Might as well do all the steps, right? Where's it going now?
Midline?
Minimum. Back to the minimum.
Yeah. So it comes in, goes up, down, up. I desperately want it to make sense that if you know the steps, you know what happens at each step. Bam. So there's a lot of work that goes into this, but if you do all the work, when you get to the graph, it's relatively easy. You know each step. Now real quick, visually, what's the period? Visually, what is the period? Yes, 6 pi over 4 minus 2 pi over 4 is, which matches up with. Yes, you can always you can check yourself as you go. Okay. Is that okay? Okay. Good question. Now, cosine's the same idea, except it would start at 3 instead of 0. Yes. What about tangent and cotangent? What's the period of tangent and cotangent?
Negative pi over 2.
No.
Oh, pi.
Pi. And they both have the same shape, just that one of them has been reflected. What does tangent go from? What does tangent go between? Sorry.
Sine.
It's my hearing.
Negative pi over 2 pi over 2.
Yes. Negative pi over 2. Pi over 2. And what's at these locations? Asymptotes. If you completely forgot that, how could you get it again? What is tangent? Somebody said it at the wrong time, but sine over cosine. Asymptotes will be where the bottom is 0. When is cosine 0? Negative pi over 2 pi over 2. Yeah. Okay. So it's it is not all straight memorization. You can always rederive what you need. And then this is kind of like where the amplitude comes into play. I know it's like a cubic. Yes. Okay. Of course, cotangent. Cotangent is this flipped. And where does cotangent live between?
0 and pi.
0 and pi. Just this being flipped. 0 and pi. Yeah. So let me say this. If you're gonna do what's called a if you're gonna do what's called a memory dump, memory dump, which is just to write some stuff down. Do it on the test. Don't do it on another sheet of paper. Because I don't know when that happened. Does that make sense? If you do it on the test, you obviously did it after I gave you the damn test. Thank you. Yes?
And then secant and cosecant live where it hits the midline. As opposed to where it hits the midline.
Yeah, so secant and cosecant. So if I want to do cosecant of this, they would have just been that, yes. So secant and cosecant is like graph the corresponding side of cosine and then just put the cups, yes. Okay. So if you can graph sine, you automatically can graph cosecant. If you have a question, fire away.
I struggled with number 12 on the final review.
Oh. Okay, so that one looked like this here. Is this right? This one,
Yeah, that's it.
and then it was. I don't have the light copy anymore.
Oh, let me read it. It's equals 2 cosecant squared x minus sine squared x minus cosine squared x.
It's not a sign on the bottom
Huh?
either.
Oh, the bottom's 1 minus cosine squared x.
Oh, yeah,
Sorry.
but I just made that sign square.
Okay, yeah.
Yes.
Do you have the effect figure of the final exam?
Oh, I just had it. I could print you out one, but I ran out of hard copies. I gave some out the other day, yes, sir. Let's see if I have any. Now I'm gonna have to print you one out, too. Okay. Is everybody cool with that? That's the good first step. Because that's what 1 minus cosine squared is. Okay. Now, this side has no fractions. So what's a good next step? That side has no fractions. So what is a good next step on the left-hand side? How do I say this another way? So what is being divided by sine squared? What is being divided by sine squared? What is being divided by sine squared? 1 and cosine squared. Thank you. Okay, so what is... So you have got to notice, physically, this side has a fraction, this side doesn't. I want to write this separated, so it becomes not a fraction anymore. So it's 1 over sine squared plus cosine squared over sine squared. That is one immediate thing I can do. So again, students don't realize that you can use one side as a hint for the other side. I know you're all like, math is painful already, dude. And now we gotta listen to this. I'm sorry, it's just the way it is. What is 1 divided by sine squared? Cosecant squared. What is this?
Cotangent.
You see how you're
Oh, yes.
a little closer? Now, on this side, is there anything I can do on this side?
Negative sine squared x minus cosine squared x is -1.
This is what I got so far, yes? Now, you could look at this side. What does this side have that this side don't? What does this side have that this side don't? Cotangent squared. Is there a relationship between cotangent squared and cosecant squared? Can you rewrite this so it goes away? Your three most fundamental identities. Sine squared plus cosine squared is 1. What are the other two identities?
Cotangent squared plus 1 equals cosecant.
Yes, cotangent squared x plus 1 is cosecant squared. Tangent squared x plus 1 is secant squared. Yes. Huh? Hell no. No freaking way. Why can't I just add 1?
It's not an equation.
Huh?
It's part
They're
of
both
it.
supposed to be the same thing.
Sure.
It's not an equation.
It's not an
I
equation.
don't know
Proving
yet if the equality is true. So adding 1 to both sides is a property of equality. I'm trying to prove that they're equal. I know it seems like a little picky point, but that's freaking math. So, can I replace this with something to do with cosecant squared? If 1 plus cotangent squared is cosecant squared, what is cotangent squared equal to?
Cosecant squared minus 1.
Cosecant squared minus 1. And aren't these the same thing? Okay. But it's all about using the other side as a hint. Use the other side as a hint as to what to do. Does one side of a fraction and the other one doesn't? Try to break that fraction up. Right. Okay, man.
Can you go over 11D on the review?
And what might that one say? Let's see, 11D. Oh, here we go. Is it side of... Is this it? Yes?
Yes.
Okay. So, this, if it was just, check, if it was just this, is that easier? Hell yeah. What would you do?
Draw.
Draw a triangle.
Draw a triangle, because an inverse trig talks about an angle that lives in a right triangle. You can draw it, yes? And then you can figure out what the sine is by figuring out the side sine needs. So, sorry. What can this is harder. That is the sine of the difference of two angles. Do we have a formula for that? That, guys, can somebody tell me what the inverse cosine of 3/5 is? No. Good. No, of course you can't. I don't know what the shit that is. So can if I wanted to, I could call it A. I don't know what it is. You know what this is? No idea. So we call it A. What's this?
B.
I don't know. B. Now, what's the formula for this?
Sine,
Sine, cosine, A plus sine.
No.
cosine, minus. Sine stays the same. Sine B.
So I need to draw a triangle for A
And B.
and a triangle for B. And then these are all pretty easy, yes? This is something you could do anytime you want to. If there's a piece of what you're working with, oh my God. I'm sorry, I just see myself as RFK and it's really freaking out. If there's a piece of what you're working with that you don't know, you can call it a letter. And then it can do more shit. So, how do I draw that? A triangle. How do I draw this triangle? How do I label it? It comes from this, yes.
Hypotenuse 5.
Huh?
Jason 3, hypotenuse 5.
Okay, the x side is 3. Hypotenuse is 5. Okay. I'm really hopeful that at this point, you guys know what the y side is without doing much work. No? Yes? Anybody know what the y side is?
4.
It's freaking 4, right? 3, 4, 5. Okay. So, just to show you, what is sine of A? What is sine of A?
4/5.
4/5. What is cosine of A?
2/5.
Okay. Now I do the same thing with B. Do you guys see that? I do the exact same thing with B. Yes. When you see an inverse trig inside of a trig, you think, you draw a triangle that inverse trig relates to, and then I can answer whatever question this crazy math guy is asking. Okay. Maybe. Inverse trig functions are what? Geometrically, what are inverse trig functions? I answered the question several times up there. What is an inverse trig function?
An angle.
Angle. It's an angle that lives in a triangle under the sea. No. Oh. So I could do this to you. What would you do? Is everybody cool with this? Here, B. What's what?
Sine is 1/4. Yeah.
And then you can build these, yes. What's the cosine of B? Is everybody cool with this? Square root of 15? Be 16 minus 1. Yes. What's the cosine of B?
Root 15/4.
And what's the sine of B?
Root 15. Oh, 1/4.
And now can't you just multiply that shit, yes? Yes? The 4's cancel. Here you get 3/20. I don't know, hopefully that's what I got on the answer key.
Yeah. Yes.
So, what if I did this to you? No, not tangent. I don't know, I might do this to you. Ah. What's in our way? If it wasn't there, it's probably easy.
Yeah, the 2.
Freaking 2, so I've got to use a double angle formula. I've got to use, I can't, the cosine is not directly attacking the angle. The 2 is in the way. I know every damn thing about the angle. I don't know anything about twice the angle. So what is a double angle formula for cosine? Give me any one you know. Say again.
Cosine squared theta minus sin.
So now if I draw this picture, yes? How do I draw the picture? You did it, Jeff. How do I label the picture? side.
Two.
Yeah, in fact, I'm just gonna do this. Screw this. Because what am I gonna do with a square, right? Right, 8/3 minus what's the sign? So then I get the square root of 8 squared.
8/9 minus 1/9. 7
Freaky. Double factorial. No. Yes.
Did you do, partial fraction?
Sure.
I don't understand how you're, or decomposing,
Huh?
or decomposing of the,
Yes, partial fraction. Wait a minute, let me see. We do some work behind the scenes. Don't look. Sure.
did you specifically do one that like squares the entire bottom part?
Squares the what?
The bottom part, the denominator?
Sort of.
That's your big, right?
All right, screw it. I'll just do this. There. So I was nice to you on this one because the bottom is already factored. Yes. How do I set up? Take a moment. Pray to whoever you want to pray to. And then write the form of the answer. If you don't know what I mean, that's bad. Because that's the first step in partial fraction decomposition. Can you write the form of the answer? And I'll tell you this much. Who's got it? Who's got the answer? Let's
X minus 1, B, x minus 1 squared. C, x plus 2.
Good. Because each bottom is linear, it's just repeated linear. So the top always has to be 1 degree less. Okay. Now what do I do? So this is funky. You're not used to this. We wrote what the answer is going to look like. We know it's got to look like that. Now what do I do? What do I do? Yeah, kill the fractions. Yeah. So we multiply by this. What's going to happen here if I multiply by this? What's going to be left alive?
X plus 2.
What's going to be left alive here?
X plus 2.
What's going to be left alive here?
X minus 1 squared.
Now, you could FOIL stuff out, collect your like coefficients, make a system of equations. You could do that. I don't understand you if you do that. Because what's a better way to do this? At least the first couple steps. What's a good next step? What sucks about this? There's so many unknowns. Yes. Now, the only true unknowns are what? No, X is the only unknown that's not truly unknown. We want X to be whatever it wants to be. What are we actually trying to get?
A, B, and C.
A, B, and C. We're not trying to solve for X. X is whatever it wants to be. Can somebody give me a value That would be really cool to let x be. If you let x equal to 1, what happens? Okay, again, what sucks? So many A, B, C shit. I know, there's 3 things I don't know. If I make x 1, what happens?
A and C equal.
A and C. or
Yeah,
something.
this term goes to 0, this term goes to 0. Why can I do that? Because x could be whatever the shit. So if x is 1, what's this?
3 minus 5.
Which is,
Negative
what's this?
2. 0.
What's this?
0.
What's this?
Bx plus 2b.
Say again, sorry.
Bx plus 2b.
No, x is 1.
Oh, that's right.
So B for
It's 3.
So what's b?
Negative 2/3.
Cool. Can we do that again? Can we do it again? Okay, I get it. One person says yes, okay, so we're gonna do it. So if x is negative 2, yes. I'll get a similar thing happen. Yes? I love you guys so much.
A and B go.
So then I'm gonna get, what do I get over here if x is negative 2?
12.
Negative 2 squared is,
12 plus 10.
negative 2 squared is. 4 times 3 is 12 minus 5 times negative 2, 12 plus 10.
Plus
22, yes? Why did I pick negative 2? Because it's the other value that makes some of these go to 0. What do I get here?
9c.
Yes. So what's C?
22 minus.
Is that the number you wish showed up? No. I don't give a shit. Fractions, who cares? Now, is there still something I don't know?
A.
Hey, I'm gonna wait a minute. Can anyone figure out a way to solve for A? Can somebody tell me what A plus C, what must A plus C be?
2x squared minus 5x.
No. Okay. Can you all see if you multiply everything out on the right hand side, what would be in front of x squared? Don't multiply everything out. Can you see if you did what would be in front of x squared?
Excellent.
If you multiply this out, what's the highest degree?
2.
X squared. So what's in front of the x squared here? A. Do I get an x squared here? Okay. Do I get an x squared here? What's in front of x squared?
C.
So A plus C must equal what? Because it must equal 3. Because A is in front of x squared, C is in front of x squared, and together they make 3, yes? Okay. Sorry, this is getting me frustrated. You don't have to multiply this shit out. I know this is going to give me ax squared plus shit. This is going to give me cx squared plus shit. Therefore, a plus c must be 3. That's the only way this can equal that. If the stuff in front of x squared equals the stuff in front of x squared, that's it. Okay. So a plus c equals 3. How does that help me?
Because then you just minus.
I know what c is. So, in general, you do this. Where'd it go? You do this as much as you can. And then you make relationships using what you just figured out. Yes? What's the answer? Well, now you just have to put this over this over this, and this over this. Yes, and then that's the answer. Yes. The whole idea of this is figuring out what A, B, and C have to be. Okay. How could I make a problem? I want you guys to make a problem where these are whole numbers. Couldn't you just start with the answer then? Couldn't you just say, all right, I want this to be 7, and I want this to be 2, and I want this to be -3, and then just work it out, put them together. You would construct a problem whose answers are nice numbers. Yes. I didn't do that. How did I make this problem? Pulled it right out of my ass. Yes. So of course the problem that I could almost bet, and I'm a teacher, so I don't know what to bet with, but I could bet that the answers would be gross because they just took it out of nowhere. Okay. Maybe. Sorry, just gotta laugh. Okay.
You do sound like JRFK.
What's up?
You do sound like JRFK.
I do.
A little bit.
God damn it.
Not quite as bad.
Okay.
Not quite as bad.
The sound, but not the ideas.
Yes.
Okay. Let's keep that some shit separate.
You don't eat roadkill?
Because that dude's flipping insane. Okay. Not sure what happened to him.
You hear about
Anyway.
when bears get on a bike and
Yeah, he ate roadkill.
I know. Yes.
For a problem, if I set up an equation, for a problem, if I set up an equation, a system of equation, can I
Yeah,
do it by the
That's what- that's the
I
first
have
thing.
to do by,
That's the first thing I said. Was you could multiply that out and make a system of equations. Yeah.
for solving the system equation, and we did not, I have missed, so by hand,
Of course.
yeah.
Sorry. You won't. On this final exam, you could check any row reduction of a matrix in your calculator. You cannot use that as your work. Yes. I think you guys have met me before. Okay. Now, Tran, in the real world, we would make a matrix and have a computer do it. But you're not there yet, kids. Too bad. You're with me. And I'm not in the real world. Okay. Okay. Man. I was gonna ask everybody to like sit up here. Probably should have. Because if I whisper, it's better. See that? Can you guys hear me? Okay, maybe I'll do this. It's better than me trying. Oh my God. Okay, guys. Anything else? What we got? It could be anything.
Those are the blue signs and upper and lower bounds.
Yes. So guys, what would Descartes' rule of signs say here? Dross. Does anyone remember what Descartes' rule of signs would say.
Leaves 2 positive or 0. 2 or 0 positive.
So there's 1, 2 sign changes.
So 2 or 0 will
So there's 2 or 0
Real root.
positive.
positive, that's right.
How do I figure out the negative?
If you make x
Negative x.
negative,
Like this.
1, 2 sections, or 3 sections, so 3 or 1.
Notice there's 1 sign change, yes.
Oh, yeah.
There's 1 sign change. So there's only 1 negative really. So it's kind of like a gambling thing. I didn't make a very good one. Let me see if I get lucky here. If I divide this by, yeah, I'm just gonna go crazy. I'm gonna synthetically divide that by, what do you got, Jeff? By 4. Yes. I'm gonna divide this by 4. How do I do that?
Break down the 3.
Is it 3?
12,
4, 12.
10, 40, 45.
What is, now, can you tell me 2 things about my result? What is not a factor of P of X?
Anything 4 in the bottom?
No. What's the specific thing that is not a factor of P of X?
X minus 4.
X minus 4. Sorry, Denny. Pointing at you. When I divide by 4, I'm actually dividing by X minus 4. Yes. Okay. So it's not a factor, yes. All of my result is positive. What does that mean?
Upper bound.
4 is an upper bound. Nothing above 4 could work. If I divide by a negative and I get all sign changes, that would be a lower bound. Nothing below that would work. Yes. Okay. Yes.
What made you choose 4?
I don't know.
Random.
I just did it in my head and saw that it would come out positive.
Gotcha.
So, yeah. This one kind of sucks because, well, for you guys it would be great because I can only break up 7 as 1 and 7.
Oh, yeah.
Can you guys make a list? I'm getting worse. Can you make a list of all possible rational real roots, please? You should get 4 of them. Actually, 8. Plus or minus. Hello, kids. Okay. Sorry. Trying something out. All right. Gonna sound like a complete dork, but that's okay. So, how do I construct this list? How do I construct it? Kids?
Factors of 7.
All right, factors of 7.
Divided by
Factors of-
factors of 3.
Divided by factors of 3. That is correct, John. Damn it, I lost it. Shit. What does that come out to be?
1, 7. 1,
7.
And of course, based on what we just did, I know that 7 won't work. Yes. Okay. Probably nothing's going to work because, again, I just made that up out of nowhere. It's almost guaranteed to not be factorable. If it was factorable, that would be freaky. Yeah, almost. Shit. Sort of almost, not really. All right. Oh. Man. Okay, what else we got?
Can you give me the 36 and 11.5?
Say again?
36 on 11.5.
Okay, let's see. Oh, okay. So they give us C, and they ask for C squared. Okay, look at C. This one, right? Is it this one? All right, Jack, you gotta help me out, buddy. What section am I in? I'm in section 11.5, and you said what now?
I did say 11.5.
Yep, and you said number
36.
36.
Where did I pull this from?
Huh?
I don't know where I pulled this from.
I could guess. Yeah, that's the problem though. I'm not sure what yours says. What does yours say?
It's the Gargarian.
Uh-huh. It's more like 11.6. No, it's more like 11.6. Yeah, see there.
Yeah.
That's 11.6. Yeah. Did I assign that one?
I don't know.
I don't think so. Oh, guys, real quick.
Might have stolen.
Look at 36. What if I gave that to you? What would you do?
Give her the decimal.
You would say, yeah, good Lord, please, get rid of the flipping decimals. What does each row represent? An equation. What does that line mean? That's where the one is. What can I do to any equation in the universe? I can multiply both sides by anything. I'm going to multiply every damn thing by 10, yes. First thing. Then it instantly becomes much better, yes. You guys see that? Anything you could do to an equation, you could do to each row. And I could multiply both sides of an equation by anything except 0. Yes? So that's what I would do. But do you have to do that? No. Dear God, please do it. Okay.
Yeah.
Is that all right?
Yeah.
I don't know if I signed that one.
I just looked at the page.
Okay.
I just did all of 11.5's problems on 11.6.
Neato. Neato. That's a choice. It's a choice you can make. Okay. That one's not as hard as it seems. If you do that, it's a lot better instantaneously. Oh, my goodness, gravy.
Could we do some completing square examples?
Yeah, dude. So what about if I ask you to look at me? I remember to switch over. Put that in the standard form. Yes. I saw that reaction. Ooh, that one's worse than I want it to be. Hold on. Make this 16. Okay. The other one would have been doable. It just would have been grosser than I wanted it to be. So, you guys remember how to put this in the standard form? I mean, we kind of gave it away because Genevieve asked for a completing a square problem, and I gave this one. So what standard form look like for this? It would look like. Yes? If I had it like this, what would the vertex be?
HK.
HK. Yeah. So how do I put this in that form? I'll take a 4 out and then make some room, yes? Shit, I should have made more room. Too bad. What do I get when I take a 4 out? I'm gonna have some room here. Let me write that again. There we go. Yeah. Okay. So, do you see how I already know what A is? Yay. How do I complete the square? What do I have to put here? How do I figure that out?
I bet you.
Yeah, take the middle term, divide it by 2. And then square, yes? Yes, remember that? Cut the middle term in half and then square it. We talked about why that works. But now we can just use it because it works. So what do I do with that? What do I do with that? What do I do with that? What do I put here? And then what do I have to put out here? What did we do? We added 16. So what do I have to do at the same time?
Minus 16.
I gotta subtract 16.
Yeah, that's right.
Did I just change the value of the problem? No, because I added 16 and I subtracted 16. Good old Indiana Jones, yes. Game is out now on Xbox and such. Right? And how does that factor? How does this factor? Like this.
X minus 2 squared.
What's out here?
Minus 15.
So what's the vertex?
2 negative 15.
Yeah. What's the y-intercept? Help. Look at the beginning. Look at the beginning. Go back to the beginning. 0, 1, yes. Yeah. So I got 0, 1. I got 2, negative 15, just to do this out of scale. So then where's another point? The reflection, yes. So it's 2 away from here, so it's got to be 2 away from here. Okay. If you do this on the test, you're going to lose points, kids. What did I not do if I had this? What did I not do? Is my scale good? If this is 1, 1, 2, 3. Yes? Okay. So on the test, you better set up a good scale. Okay. So you guys realize setting up a scale is a huge part of this class because it's supposed to help you. When you get to calculus, making quick sketches should be easy now that you've gone through all this craziness. You guys remember that? Get the vertex. You can get the reflection point. Because the vertex is on the mirror, so you get a reflection point. Man, you're done. Yes? Okay. If I wanted to know what the x-intercepts were, what would you do?
I'll make X 0. Or
No,
No,
that's the y-intercept.
set it equals 0.
And use the
quadratic.
quadratic formula. Yeah. If I wanted that, right? I wanted somebody to say, well, you'd be disappointed. one once you want to. So that's standard form of a parabola. Yeah, that could be on there.
If you plug 0 into the factor form, you'd still get the y-intercept, right?
Into what now? Into this one?
Into that one, right?
Yeah.
It's still, okay.
0 minus 2 is negative 2 squared is 4 times 4 is 16 minus 15 is 1. Yeah. It's just people make a mistake.
Yeah, it's easier.
They'll
to
just
see
go,
the top.
oh, it's, no,
Yeah.
this isn't 0. This is, yeah. Well, I gotta tell. Okay. But really,
That was pretty good.
just lean all the way in. You know, this, you can't trust that. I'm sorry. I don't mean to make fun of him. Yes, I do, because he's a piece of shit.
How's that amplifier?
Sorry if you like RFK Jr. You're in the right place. You have a chance. You're in college. There's a chance for you. I'm hopeful. Okay. Yes. 14. Oh, so what I said yesterday on 14, and I think it starts off like this. Yes. So the part I'm not going to test you on is the conic sections part, because we didn't actually do that. I'm probably going to put a conic section bonus question, because that section is extra credit, yes? So chapter 12 and 13 are extra credit. We talked about it a little bit yesterday. I could still give you this problem though and say, transfer this into XY, into rectangular coordinates, yes? Now, when I give you this kind of problem, your eyes should be drawn to stuff like sine theta. What do you wish was in front of sine theta?
R.
You wish there was an R in front of sine theta, yes? R by itself sucks, because what's R squared? What's R squared?
That's plus y squared.
X squared plus y squared. If I see R by itself, that's the square root, that sucks. So everything's working together. I need you to agree with me. I wish there was an R right there. Good Lord. I don't know. I have another class to teach later. Hello. Okay. So how do I get an R to show up right here? What do I do to everything?
Multiply by R.
Multiply by R. This is R squared.
It's 3R squared.
See that? The R goes to each thing. Now, what's R squared?
X squared plus y squared.
And what's R sine theta?
Y.
Because I want to know. And what's R squared cosine squared?
3x squared.
Right, because R cosine is X. So R squared cosine squared is X squared. Now, from the little bit we talked about yesterday, could somebody tell me, would that be a circle, an ellipse, or a hyperbola? You could do one thing, yes. What's this? Why is it not a hyperbola?
It's addition.
It's addition between the squares. Why is it not a circle? Coefficients are not the same, so what is it?
Ellipse.
An ellipse. But on the test, I would have you stop there, because we didn't officially do conic sections. Yeah. Here you'd have to complete the square. I think I did it on the answer key, just because I couldn't stop myself. Oh man, I was so hopeful last night I'd wake up with some voice. Apparently it's not true. Okay, okay. Shit. Okay. Yes.
What were 9C?
Oh, okay. How did that start off like that? So was it this year? Yeah, okay.
Minus ln x squared minus 1.
Okay, yeah,
That's not right.
okay. So, do we have properties for the addition of logs and the subtraction of logs? Yes, in fact, what is log A plus log B? Log A plus log B.
Multiplication.
Log A. What's log A minus log B?
Log A minus
Log of A divided by B. Okay. There's one thing that's in our way, because I don't have a clue what 2 log A plus log B is. I know what log A plus log B is. So what's in my way?
2.
A dumb 2. What can I do with that dumb 2?
Put it up top.
Yes. Okay, now I'm left with sums and differences of logs. And then, well, like, how do I rewrite this?
X minus 1 squared times x.
Okay, how do I rewrite this?
X minus 1 squared times x divided by x squared.
Now, if you stop here, you're gonna lose some points because, can't I simplify this a little bit?
Yes.
Could I cancel an X out? Don't agree with me because that's wrong. Yes?
No.
I can't do that because division can't cancel. I can factor the bottom and then division will cancel multiplication. Yes? Okay. So if you factor the bottom, one of those X minus 1s cancels. Sorry on the answer key, I already wrote it. I'm gonna write it again. Oh boy. Everybody got an answer key, yes. Okay, I sent out the practice final over email, yes. Or no? I think I did.
Yeah, it's on Canvas.
Thursday. So anything you haven't turned in yet, if you give it to me today versus Thursday, it's the same thing. The same, yeah. So if you haven't done test 1 corrections yet, you can still do them. You can still get some points back. What's actually a little more important is it's a great way to study for the final. Yes? So correcting any tests you haven't corrected yet could increase your grade directly, and then it could increase it indirectly as you're studying for the final. Okay, maybe. Yes.
Is tomorrow the calculator or no calculator?
Tomorrow's the no calculator. So whatever that does to your preparation, you can adjust accordingly. Yes. Sleep with the calculator strapped to your head. So you wake up like, oh shit. So obviously tomorrow is going to include questions like, what's the sine of 5 pi over 6? Because I want you to do that without a calculator, right? There's other things on there, obviously.
You said it's gonna be about, what, you think about 15 questions tomorrow roughly?
Oh, geez.
I think you said a total of about 30 for both.
It's going to total about under 30, so it's total under.
On both tests or one test?
Huh?
Is that on both tests?
Both tests. Yes, that would suck to have 30 questions across 2 days. No.
For 1 hour.
No, that would be too much. Yeah.
Maybe in the old days, right?
Huh?
It was like 2 hours for the final.
Yes. Yes.
It used to be 3 in the 80s.
I know. Well, it used to be 3
Here
more
too.
recently here. Oh, well. I'm sure you guys really hate the fact that I can't give you a 3-hour final. Oh, well. Dadgummit. All right. I'm really sorry about this, but don't forget though, you got the other, I can't remember if there's any more left, the other reviews. Yes, it's on the bottom of that schedule I gave you guys.
Yeah, 175s are left.
Yeah. Oh, here we go. What is today, the 10th?
Yeah.
So Nemi is awesome. She,
Yeah.
175 is 176 minus trig. So if you go to one of those reviews, Nemi's got her voice, which is a bonus. She's an awesome teacher. This is a bonus. You know, it's up to you. You don't have to. They're just there if you want it. I feel really bad that I'm not really here. I do. I feel bad. But you've got, she's opened up her review for everybody. I'm kind of happy I didn't, because people get this. You can go, guys. You can go. I love when people get some, they're holding their bags like, just freaking go with college. So I'll see y'all tomorrow. I'll bring some snacks. If you guys can watch me. Oh, I'll let you have something.